Hey everybody, Mr. Quick here. Welcome to Eureka Math / Engage New York Math, Module 5, Lesson 13, the formulas for volume. In this lesson, so we've already talked about the formulas for volume. In particular, we've said volume equals length times width times height. And we've also said that volume equals the area of the base, which is length times width, right? We'll say area of the base times height. That's how we find the volume of a rectangular prism. Now, what we're going to do today is, one, do a couple of practice problems to reinforce those skills, and then two, look at what we can do with these formulas and what we can learn from these formulas as we put them into practice. So let's get started. All right, example 1. Determine the volume of a cube with side lengths of 2 1/4 centimeters. Already I know I'm going to have to create my cube, right? Good enough drawing, doesn't have to be a perfect drawing. But I know that the side lengths are going to be 2 1/4 centimeters. So I've got a 2 1/4 length, 2 1/4 width, and a 2 1/4 height. So if we're going to say length times width times height is our formula, then in this case, we're going to have 2 1/4 times 2 1/4 times 2 1/4. To simplify that, I'm going to use my MAD formula, which is multiply, add, and the denominator stays the same when I go from a mixed number to an improper fraction. 4 times 2 is 8, plus 1 is 9, so we're going to end up with 9/4 times 9/4 times 9/4. I say that because we have 3 of these, and if that's 9/4, then we're going to have 3 9/4. So, as we multiply, we know we just multiply straight across. 9 times 9 is 81. 81 times 9 is 729. 4 times 4 is 16. Times 4 is 64. So we have 729/64 centimeters cubed. And of course we can simplify that by dividing 729 by 64. For purposes of time in the video, we won't do that now, but you know how to simplify that. Okay? Now, for example 2, it says determine the volume of a rectangular prism with a base area of 7/12 feet squared and a height of 1/3 feet. So we don't know the length or the width if we're going to use length times width times height. Length, that's always tough for me. Length times width times height. But the area of the base would be length times width. So I know that those two together are going to be 7/12 times the height, which is 1/3. We can multiply across. We end up with 7 times 1 is 7. 3 times 12 is 36. 7/36, we're talking about feet. And since it is volume, it is cubed. 7/36 feet cubed. Okay. This one, we're going to go over a few different questions involving this. Okay, first thing is fairly simple. Determine the volume of the prism. Well, we have the area of the base as 13 halves, and then we have the height as 5/3. So we're going to take 13 halves, feet squared, right, times 5/3 of a foot. 5 times 13 is 65. 2 times 3 is 6, so we end up with 65/6 feet cubed. I'm going to switch to blue, and we know that 6 goes into 60 10 times. Between 60 and 65, there's 5. Denominator is the same, so we end up with 10 5/6 feet cubed if we want to simplify. Now, follow-up question. What would the volume of this prism be if the height was doubled? So if we doubled the height, right? So 5/3 times 2 would be 10/3. So instead of 13 halves times 5/3, if we said 13 halves times 10/3, or excuse me. Yeah, 10/3, that's right. 13 times 10 is 130. 2 times 3 is 6. So already you can see 65 doubled is 130. Denominator is the same. And then if we, that's obviously feet cubed, and if we simplify that, we'd end up with 21 2/3. Now, the point we want to look at here is that if we doubled the height, we doubled the volume. 65/6, double that, you get 136. 10 5/6, double it, you get 21 2/3. So what you do to the height, whether you cut it in half, then the volume would be half. If you double it, the volume would be double. If you triple it, the volume would be triple. Whatever you do to the height, the volume corresponds proportionally. So it's a proportional relationship. So whatever you do to the height, if you double it, triple it, it's 10 times bigger, then the volume will be doubled, tripled, or 10 times bigger. If you cut it in half, then the volume will be cut in half. Okay, we're going to call it quits there. We'll do some more examples in class, in which case we'll see. Well, I want to show you one more thing actually real quick. If we have, let's just say we have a prism, and let's say its sides are all 3. 3 length, 3 width, 3 height. 3 times 3 times 3 would give us 27, let's say we have feet, right? 27 feet cubed. If, and again, that problem was 3 times 3 times 3. If we wanted to cut these in half, then we would end up with 3 halves times 3 halves times 3 halves, right? If we wanted to cut it into fourths, they're 1/4 as long, then we'd end up with 3/4 times 3/4 times 3/4. Okay, so I just wanted to show you that fractional amount there. The math we can do on our own. We'll do some more examples there, but I wanted to show you how that works. Okay, thank you for watching. We'll talk more about this in class. We'll see you soon.